Assignment number 8 you are saying. Alright. Have you already solved?
Yes, ma'am. My first question is wrong in assignment.
Okay.
My there is equipment, ma'am. Please wait.
One second. I'll also open this. Assignment 8. Do you want 20? Oh, okay. So the due date is over.
In eighth assignment, first question is regarding the probability using CLT theorem.
Hmm. Yes.
I have find answer 0.92 something, but in assignment, uh,
Hmm.
they are showing answer is lying between some range. Then
Yes.
how can it possible? Because they are just asking the probability.
Average. So if you get some answer within this range, I think that will be acceptable and you will get 1 point. So how much did you get the answer?
1 minute, I will tell you.
Can you see my screen? I'll just stop presenting and 1 second. I'll just open.
Ma'am, can you provide me the
This
solution of
one.
this assignment, 8 number assignment?
8 assignment.
Yes.
Okay, I can try. Do you need it now? All right. So I have a certain set of problems. This one I can solve
In
for
the
you.
yes, as
Yeah.
clearly it is written that probability that average time of electric bulge exceed 1050 hours. Then in answer is just giving the range of the. How can it possible?
No, that if you have to supply one number. If that number falls within this range, I think that you are going to get marked with a +1.
I have
So
written their answer is 0.9207.
also it is not falling within this range. No, that's why your answer was incorrect, I
Madam,
think.
please tell me how can this
All
answer
right.
will.
All right. You want me to solve this one?
Yes.
Fine. So the lifetime of a certain kind of electric bulb is considered. So let's
Here we
say
have to find probability x is greater than 1050.
yes. So x is a random variable which is, let's say,
Greater
lifetime.
than.
This is
मैम इससे
my
शॉर्ट
random
में बता दीजिए
variable.
प्लीज.
Actually, this will be recorded and this will be used by other people also. So I have to explain each and every step.
ओके ओके ओके.
Please just bear with it. So expectation of this thing.
सिग्मा इज 250 आवर्स.
Variance of x is 250 whole square. Okay. Sigma is 250. Fine. So what is the probability that average lifetime of bulb exceeds this thing using central limit theorem? Average lifetime of electric bulb of a certain kind of electric bulb. Alright, so let's say x, you have a sample which is from this distribution with this mu and this sigma. So
ओके.
then average lifetime will be summation xi by n, y equal to. So now you have to find out probability y average lifetime. This is greater than 1050. So you have to find out expectation of y, which is summation expectation of xi by n, which will be 1000. and variance of y will be summation, you are assuming IID, so summation of variance of yi by n, sorry, n square, this will be 1 by n variance of yi, so this will be 250 by n. uh, yes, so this one you have to find out this probability y minus 1000 by 250 by n is greater than 1050 minus 1000 by how many have they given? Lifetime is considered as random variable with mean this and SD 250. Okay. Oh, this thing they have not given. This
Yes.
said that the lifetime of a certain kind of electric bulb is considered as a random variable with mean this. So what exactly did you do?
Wait, I will tell you. I simply solved x minus 1000 divided by 250. In this way, I have got answer 0.920. That's
This
why
is
I'm
50
not getting
by,
right.
so this is probability y greater than 1050 is probability, sorry, x, you are saying x, this is 50 by 250.
250. That is z greater than
Ah,
0.2.
so this
Probability
is probability x greater than
0. Point.
0.2, 1
That is 1.
minus probability x less than 0.2.
And it is 0.0793.
This one is how much?
0.0793.
0.0793.
When we subtract it from 1, it will be 0.9207. 93.
0793.
And it is
Okay.
0.9207. 0.9207. I have written this answer in the option, but n is missing here, so how can we find average life?
N is missing. Yeah. So
In the
this one is a typical random variable. I think some information is missing over here.
in the same way, question number 6 I have also got a wrong answer.
Hmm.
उसको भी मैंने इसी ढंग से किया था, but I haven't get the correct one. They have not accepted my
Question
answer.
number 6 is a bank teller serves customer standing. Suppose that xi is the service time for customer I, has mean expectation xi equal 2 minutes, variance 1. Assume that variance service di from, okay, let y be the total time. Alright, so here also for question number 6.
Now, ma'am, now question. What to do? Question number 1. Is it wrong statement?
Question number 1, I am not so sure because uh, this one, some n should have been mentioned, I think. You can put a mail to the NPTEL team stating your concern. I think they are going to respond.
Madam, we cannot get the solution from MTL from this assignment. When we start this course, they send us the solutions for the first 3
Yeah,
assignments.
that's what I'm seeing. So,
But now they are not sending us the exact solutions of these assignments. They're just giving us the, yeah, it is correct or not.
Okay,
So,
so what I can do from my end is I could probably over the next couple of weeks I could provide the solutions. So
okay, ma'am.
few of them I can solve right now. So this one, let me see if I can do it. A bank teller, this is expectation of
Nee-
xi probability. You got this right?
Ma'am, yes, you please tell me the question number
Question number
uh,
6.
fourth. Fourth, nahi, once. Eighth question.
Question number 8. This yn is 0 1 by n. As n tends to infinity, it will go to 0. See, some things you can just do with your intuition as well. As n is going increasing, 0, the this interval is getting shorter and shorter and shorter.
Okay. That's why it will go to question number two from just idea.
No, just not from just idea. This one will go in Poisson. You are just rushing too fast. I mean, can you please spare some time so that I can go one by one?
Okay, ma'am.
That will be easier for me. Okay, so I'll solve question number 6 first. So they are saying a bank teller serves customers standing in queue one by one. Suppose xi is the service time for customer I, mean this thing variance. Okay, fine. Y equal to total time. So this one I can write it as x1 plus x2 plus x50. Alright. So then expectation of y will be summation I equal to 1 to 50 expectation of xi, which is 2. So 50 into 2, this will be 100. Sorry. Alright, this will be 100. Then variance of y will be summation I equal to 1 to 50 variance of xi, since this is independent. So this will be 50 into variance was standard error was variances was 1. Okay, so this will be 50. Then we have to find out probability 90 less than less than y less than 110 is probability by root 50. So this will be minus 10 by root 50 so how much does this come to? This will be this will go to by CLT 2 5 10 by root 50 minus 1. So how much do we have? 2 by 10 by root 50. 10 divided by square root of 50. So this will be 2 phi of 1.41 minus 1. So phi of 1.41 is 0.4207. So this will be 2 into 0.4207 minus 1. So no, it's coming negative. 1 second. How much is this? Okay, so P norm 1.41 is how much? 0.92. 9207. So this will be how much? 2 into 0.9207 minus 1. This will come close. This is equal to 0.84. Is that the answer? Yes, 0.84 is falling within this range.
Okay, ma'am. Thank you.
What was the problem here in this question?
Actually, I'm not getting the correct answer. That's
You
why.
you followed this procedure?
Yes, I tried, but I haven't get. Ma'am, actually, I haven't taken the square root of 50. That's why I'm getting wrong.
Oh, okay. This was square root of 50. Okay, then you were talking about this one. Let x be a sequence of random variable. Xn follows this. Which of the following is correct?
Okay, ma'am. Thank you. Now I'm leaving the meeting.
Alright.
Thank you, ma'am.
Alright. Thank you, Dr. Gaurav. Alright. So I will move on and solve a few more questions for the others to see and work around. So, as Dr. Gaurav was saying, sorry, so if we have a problem like this, that please pardon me for this haphazard thingy. All right. So question number, this one was let xn be a sequence of random variable. So question number 2 is let x1 x2 dot xn be a sequence of random variables such that xn follows binomial n comma lambda by n. N belongs to n greater than lambda, and lambda is greater than 0. Then where does it converge in distribution to? So all right. So here what we have to do is f of xn is probability xn less than equal to x. So this will be summation I equal to 0 to x nci lambda by n to the power I 1 minus lambda by n to the power n minus I. Okay, so now what do we do? Alright, I'll come back to this problem once again because so I'm going to move on to the next few problems and then we'll see how we fare. So let us have two independent random variables x and y, then find the joint distribution of minimum of xy and maximum of xy. So let's say let u equal to minimum of xy and v equal to maximum of xy. So probability v less than equal to small v is that probability max of xy less than equal to small v, which implies both x and y should be less than v, because if v is here, this could be x, this could be xy. So maximum is less means all are less. So this would, since these are independent, we can write it as probability x less than equal to v into probability y less than equal to v. Alright, so this will be 1 minus fxv, this will be fxv into fyv. So this will be 1 minus, since both are exponential lambda, this will be 1 minus e to the power minus lambda v into 1 minus e to the power minus lambda v. Whole square. Alright. Next we have to find fu u. This is probability u less than equal to u, 1 minus probability u greater than u, 1 minus probability minimum of xy greater than u, 1 minus probability x greater than u, y greater than u. Since minimum is greater than x and y, so all will be greater than this thing. Since they are independent, we can write it as this. Alright, then we can write this as 1 minus f xu into 1 minus fyu. This will be 1 minus e to the power minus lambda u into e to the power minus lambda u, 1 minus e to the power minus lambda 2 lambda u. Alright, so we got fv, and so we got the marginals of u and v. Now we have to find out the bivariate distribution. So in order to find out the bivariate distribution, we'll write probability u less than equal to u, v less than equal to v. This will give us the bivariate. This is equal to probability minimum less than equal to u and maximum less than equal to v. So this can be, when since there are only two variables, if minimum is x then maximum is y, so this can be x less than equal to u, y less than equal to v, or the other way around, y less than equal to u and x less than equal to v. Now we can write, by independence we can write it like this, into probability y less than equal to v plus probability y less than equal to u, probability x less than equal to v. So this will be fxu into fyv plus fyu into fxv. Alright, and then we are going to substitute our values over here, and whatever we get, that will be the answer. I hope this is okay. So if this is okay, then we'll move on to the next one. Okay. So this problem here, it states that let xn be a sequence of IID random variables taking values in the interval 0, half. If expectation of xn square converges to 0 as n tends to infinity, then which of the following is or are correct? Xn tends to 1 in probability, xn tends to half in probability, xn tends to 0 in probability, and xn tends to 0.75 in probability. Alright, so we are given expectation of xn square, this is going to 0 as n tends to infinity. So we can write this as variance of xn plus expectation of xn whole square tends to 0 as n tends to infinity. Alright, now variance of xn is greater than equal to 0 and expectation of xn square is also greater than equal to 0. So if you have two positive quantities and or rather non-negative quantities which are going to 0 as n tends to infinity, then this implies that individually they must also be go to they must also go to 0 as n tends to infinity. Okay, so we have this. Now we have to find out xn goes to what in probability. Okay, so we can write it as probability xn minus expectation of xn greater than epsilon will be less than equal to expectation of xn minus expectation of xn whole square by epsilon square by Chebyshev's. Okay, so this will be variance of xn by epsilon square. Now this thing goes to 0 as n tends to infinity. So therefore probability xn minus xn less than infinity, this goes to 0. So this means that xn goes in probability to expectation of xn, which is 0. Another way to do this is, so from here we have an idea that this is going to 0. So we can write this as probability xn minus expectation of xn sorry probability xn greater than epsilon is less than equal to expectation of xn by epsilon. This one we can write as by Markov's inequality. Okay, now let us consider a function gx equal to x square. This is a convex function. So now by Jensen's inequality we have expectation of gx is greater than equal to g of expectation of x. Alright, so then we can write this as expectation of x square is greater than equal to, or mod x square is greater than equal to expectation of mod x whole square. So we can write it as expectation of x square to the power half is greater than equal to expectation of mod x. So this one, let this be equation 1. Then from equation 1 we have probability xn greater than epsilon is less than equal to expectation of xn by epsilon, which is less than equal to expectation of xn square to the power half by epsilon. Now this term, it goes to 0 as n tends to infinity, because this is given. Expectation of xn square goes to 0. So therefore we have xn goes to 0 in probability. All right. So now we'll move on to the next one. So let x1, x2, xn be n independent Poisson random variables with mean 1 to n. Find an x such that this happens. Okay. So sorry, Sn equal to summation xi equal to 1 to n. Okay, so expectation of xi is given as I, and variance of xi is also given as I. So expectation of Sn will be summation I equal to 1 to n expectation of xi, I equal to 1 to n I, this is n into n plus 1 by 2. Alright, and variance of Sn, since they are given independent, this will be summation I equal to 1 to n variance of xi, summation I equal to 1 to n. Now mind you, here we can write this as variance without any covariance terms because they are independent Poisson random variables. Had there been any dependency, we would have to mandatorily include covariance terms over here. Since we do not have that situation, we are writing it like this way. Please bear this in mind. If nothing is told about independence, you cannot write variance of summation xi equal to summation of variance of xi. Alright, so this will be same n into n plus 1 by 2. So now we have to find out this phi x. So probability Sn minus n square by 2 by n less than equal to t equal to phi x. Alright, so we can write this as probability Sn minus n square by 2 oh alright, no, so Sn is summation xi. So probability Sn minus expectation of Sn by root over variant of Sn less than equal to x will go to phi x by CLT. By CLT this will converge to a normal distribution and this will be phi x. So we'll put everything here. So probability Sn minus what was expectation of Sn, n into n plus 1 by 2 by root over n into n plus 1 by 2 less than equal to x equals to phi x. So we'll just solve this thing. Okay, so now we have probability Sn minus n into n plus 1 by 2 by root over n into, we'll remove probability, n into n plus 1 by 2. This can be written as n minus n square by 2 minus n by 2 by root over n square n plus 1 by 2, sorry, root over n into n plus 1 by 2. So here we need something like by n. So if I have to incorporate n over here, then if I write n here, I have to write n square over here. So we can write this as Sn minus n square by 2 minus n by 2 by n root over n cancels, n plus 1 by 2n. Okay, so then we can write this as Sn minus n square by 2 by n into root over 2n by n plus 1 minus n by 2 by n root over 2n by n plus 1. So we can write it as Sn minus n square by 2 by n root over 2n by n plus 1 minus half root over 2n by n plus 1. Okay, so from here, this less than equal to x. So this less than equal to x, we had something like this less than equal to x, less than equal to x implies Sn minus n square by 2 by n less than equal to x plus half root over 2n by n plus 1 by root over 2n by n plus 1. So this we can write as Sn minus n square by 2 by n less than equal to x root over n plus 1 by 2n plus half. So therefore, comparing t equal to x root over n plus 1 by 2n plus half. Now this will be reversed, this will be t, this will be x. Alright, this will be the answer. Okay, so we'll move on to the next one, and meanwhile I'll put this okay. Fine. So now let us consider a random variable omega which belongs to the sample space 0 to 1 and omega is uniformly distributed. So here what we have, omega follows uniform AB, okay, where 0 less than equal to a less than equal to b less than equal to 1, and we have a sequence xnw defined by xn omega is 1 or 0 in this context. Now we have to find out where or whether how the convergence is happening. Okay, so first things first, we'll try to find out if it is almost surely converging. So for almost sure convergence, we have to show that summation n equal to 1 to infinity oh, alright, so there are other ways to show this as well. So first we'll find out the distribution of this thing. Okay, so this difference will be 1 only when this is 0, that is omega is greater than half, and omega falls within this range. So this is 0 and this is 1. Only then this will be 1. Otherwise, everywhere it will be 0. So we can write this as it will be 1 when half less than equal to omega less than equal to n plus 1 by 2n. And it will be 0 if less than equal to omega less than half. Okay. So x and omega, if it is 1 and x omega is also 1, then it will be 0 in this range. If both are 0 outside these ranges, so now we have to find out if xn converges to x absolute sure sense, because if this holds, if absolute sure holds, then it converges in probability, then it converges in distribution. All right, so for absolute sure convergence, what we have to show? We have to show that limit xn and x, limit xn tends to x, and that probability goes to 1. Okay, so now we have to show probability limit n tends to infinity xn equal to x, this is 1, or in other words, we have to show that probability xn omega minus x omega greater than epsilon for all epsilon greater than 0, this probability is 0. Okay, so now probability xn omega minus x omega greater than epsilon is equal to probability oh sorry this is convergence in probability which I am showing right now. We will see greater than this is the probability this probability equal to probability half less than equal to omega less than equal to n plus 1 by 2n. Now omega they have said belongs to a comma b. So then this probability, and this is uniform. So this probability will be n plus 1 by 2n minus half. This will be n plus 1 by 2n minus n. This is 1 by 2n. This goes to 0 as n tends to infinity. Therefore, xn omega goes to x omega in probability. Okay, so in probability means xn omega goes to x omega in distribution as well. Alright, now we have to show if it holds true in absolute convergence also. So for that we have to show that xn omega goes to x omega. So here xn omega is what? 1 if 0 less than equal to omega, or in other words we have to show is that limit of n tends to infinity xn omega minus x omega is 0 and that probability equal to 1. So now we have the distribution of xn omega minus x omega 1 and 0, half less than equal to omega less than equal to n plus 1 by 2n less than half. So xn minus this one, this will go to 1 as omega will go to half and this will go to 0 otherwise. Okay, so now this one is equal to 0, so what it means to say is that this one will take value 1 with probability 0. So this one we can write as probability limit n tends to infinity xn omega minus x omega not equal to 0 is 0. So probability limit this thing xn omega minus x omega not equal to 0 is probability omega equal to half, which is equal to 0 since omega belongs to uniform distribution. Since omega is from a continuous distribution, this thing is 0. Alright, so therefore we have xn omega goes to x omega in absolute sure sense. Alright. Fine. Let's move on to the next one. Okay, so this is question number 5. Let omega script fp be this. Let xn be a sequence of random variables such that xn is equal to intersection of 1 by 2 minus 1 by n and half plus 1 by n. Okay, now which of the following is or are correct? Alright, so xn is identically distributed with half minus 1 by n random variable, this one, and half plus 1 by n. So since this is intersection, so let's say we have x1, this will be half minus 1 half plus 1. x2, the interval will be a little smaller. x3, this will be a little smaller. Okay, so x1 is this, x2 is intersection of x1 and x2, so only this region. x3 is intersection of these three, so only these three sections, the smaller sections. This is, since this is an intersection, so therefore xn will be uniform half minus 1 by n half plus 1 by n. Now where does it go in distribution? So to find out distributional convergence, we have to find out probability xn less than equal to x. So this will be 0 if x less than half minus 1 by n, will be 1 if x is greater than half plus 1 by n, and this will be x when x belongs to closed 1 by n, half minus 1 by n and half plus 1 by n. So it is uniform AB, it will be x minus a by b minus a. So it will be x minus half minus 1 by n by half plus 1 by n minus half minus 1 by n. So this we can write as 0 if x less than half minus 1 by n, 1 if x is greater than half plus 1 by n, and x minus half minus 1 by n by 2 by n when x belongs to half minus 1 by n and half plus 1 by n. Okay, so we got this one. Now the question is, as n tends to infinity, what happens? F of xn probability xn less than equal to x I'll write it here, 0 if x less than half minus 1 by n, 1 is x greater than half plus 1 by n, x minus half minus 1 by n by 2 by n when x belongs to closed half minus 1 by n and half plus 1 by n. Okay, so as n tends to infinity, when this will go to 0 when x is less than half, 1 by n goes to 0, 1 when x is greater than half because 1 by n is again going to 0, and when x, this interval is getting smaller and smaller around 1 by 2. So when x at limiting sense, x will be equal to half because it is closed, and at x equal to half, this value will be half minus 1 by n plus 1 by n by 2 by n, that is half. Okay, so this is a discontinuity point. Alright, now it is asking, this is the limiting distribution, limiting CDF. Is it asking, is it converging in distribution with to x where x equal to half? So if we have an x equal to half degenerate, so if we have x equal to half degenerate distribution, then fx would be 0 if x less than half and 1 if x greater than equal to half. But what do we have? Our limiting distribution. So that we had fxn goes to 0 as x less than half, 1 as x is greater than half, but half as x equal to half. Therefore, xn doesn't converge in distribution to x. Okay, because this has to hold for all x. For all x, this is not happening. Alright. Oh, so here it is written that sorry, this does converge in distribution, sorry, because it is converging at all continuity points. Half is a discontinuous point. Okay, so this follows, this converges in distribution to x. Alright, next we'll move on here. Let x1, x2, x25 are IID random variables with the following PMF, and let y equal to x1 plus x2 plus xn. Using CLT, what is the probability? Probably 4 less than equal to y less than equal to 6. Alright. So expectation of y will be expectation of x1 plus x25 equals to 25 into expectation of x1, because this is IID. So expectation of x1 will be 1 into 0.6 plus minus 1 into 0.4, that is 0.2. Variance of x1 is 1 into 0.6 plus 1 into 0.4 minus 0.2 whole square, that is 1 minus 0.04, that is 0.96. So this will be 25 into 0.2, that is 5. Variance of y equal to summation variance of yi is 25 into 0.96, that is 24. So then using CLT, probability 4 less than equal to y less than equal to 6 equal to probability 4 minus 5 by root 24 less than equal to y minus 5 by root 24 less than equal to 6 minus 5 by root 24, probability 1 by root 24 minus less than equal to z, so it goes to 1 by root 24. This will be 2 phi of 1 by root 24 minus 1. 1 by root 24 will be 0.5808. This will be 0.16 something. It's not matching. So phi of 1 by root 24 is how much? 0.2. Zero point 0.0793. Zero point 0.0793 if we write here, 2 into 0.0793. No. This is probably okay, so this is 1 minus. I'm not so sure what this table. Okay, so standard normal table. Area between mean and some z score. Okay, so this is the area that is it is providing. Then here 0.2, this is 0.0793 into 2. Okay, 1.45, this area it's providing, right? So okay, so then we are finding out this part. Okay, so we are finding out in essence so this will be 2 into 0.0793 and that will be 0.1586. Okay, so maybe B is the answer. Okay, so this is how you have to solve such questions. We'll move on to the next one. So let x1, sorry, let x1 x2 xn be IID exponential lambda with, let x bar be x1 plus x2 plus xn by n. How large should n be such that probability 0.9 less than equal to x bar less than equal to 1.1 greater than equal to 0.95. So x bar is summation xi by n. Expectation of x bar is how much? 1 by n summation expectation of xi. Each xi IID lambda 1, so it will be 1 by n summation lambda which is 1. Variance of x bar is 1 by n square summation variance of xi equal to 1 by n square summation of exponential lambda. So this will be lambda square. Okay, so let us consider this is mean lambda. Okay, so then this will be lambda square, which will be lambda square by n is equal to 1 by n. Alright, now we have to find out probability 0.9 less than equal to 1.1 greater than equal to 0.95. So it's probability 0.9 minus 1 by root 1 by root 10 less than equal to x bar minus 1 by root over 1 by n less than equal to 1.1 minus 1 by root over 1 by n equal to greater than equal to 0.95. So here we can write this as probability minus 0.1 root 10 less than equal to z less than equal to this root 10. So then this greater than equal to 0.95. So then we have 0.1 root 10 is equal to 1.96. Okay, because we know that if it is minus 1.96, then this is 0.025 and this is also 0.025. So within greater than equal to 0.95 means this should correspond to 1.96, which means root 10 should be 19.6, n should be 19.6 square, which is how much? This is 384.16, so therefore n should be 385. Okay, all right, excuse me. So let us assume that we have invited 64 guests to a party. We need to make sandwiches for the guests. We believe that a guest might need 0, 1 or 2 sandwiches with probabilities 1/4, half and half. Assume the number of sandwiches is independent of other guests. How many sandwiches would you make so that you are 95% sure that there is no shortage? Okay, so let us assume xi is the number of sandwiches consumed by ith individual. So total number of sandwiches y should be x1 plus x64. Is it okay? Now we have to find probability y greater than equal to y or rather probability y less than equal to y is greater than equal to 0.95. Alright, now we'll have we have to find out small y. Okay, so now expectation y equal to summation of expectation of xi. Expectation of x1 is how much? Acha, so each xi can take 0, 1 and half with probability 1/4, half and 1/4. The expectation of xi, which is 0 into 1/4 plus half, 1 into half plus 2 into 1/4, that is half plus half, that is 1. Variance of xi equals to 1 into half plus 4 into 1/4 minus 1 square, that is 1 plus half minus 1, that is half. Okay, so variance also we have. So then the next thing is to find out the variance is also half. Now we have to find out summation xi variance. So here we have y equal to summation xi. So expectation of y will be I equal to 1 to 64. 64 into 1 is 64. Variance of y is also 64 into half, that is 32. Alright, so then probability y less than equal to y equal to probability y minus 64 by root 32 less than equal to y minus 64 by root 32. So this one greater than 0.95, which implies y minus 64 by root 32 should be equal to phi inverse of 0.95. Okay, so then something less than this thing is 0.95, greater than 0.95. So this is a normal thing. This entire area is 0.95 and this is 0.05. So this one, given that it's a standard normal, this is 1.64. So this is 1.64. So now we have to do y minus 64 by root 32 equal to 1.64. Y equal to 1.64 into root 32 by 64. We'll see how much it comes to. Into square root of 32 divided by 64. So this will be close to 0.14, but this shouldn't be. 1 second. Sorry, I'm making mistake. Sorry for this calculation mistake. So this would be, y would be 64 plus 1.64 into root 32. So that would be this is equal to 73.27. So therefore we would have y equal to 74. Therefore total sandwiches to be made equal to 74. Alright, so we'll move on to the next one. Okay, so in a communication system, each data packet consists of 1000 bits. Due to noise, each bit may be received with an error probability of 0.1. Assumed bits occur independently. There are more than 120 errors in a certain data packet. So let's have y okay, so in a communication system, in each data packet consists of 1000 bits. Due to noise, each bit may be received with a there are more than okay, so there are 1000 bits. So y equal to x1 plus x2 plus x1000, let's say. Okay, so expectation of y will be 1000 into so each xi equals to 1 with probability 0.1 and 0 with probability 0.9. So this would follow a binomial 1000 0.1. So expectation of y would be 1000 into 0.1, that is 100, variance of y would be 1000 into 0.1 into 0.9, that is 100 into 0.9, that is 90. So probability more than 120 errors in a packet. So probability y greater than 120 equals to probability y minus 100 by root over this 190 is greater than 120 minus 100 by root 90. So this is 1 minus phi of 20 by root 90. This will be how much? One minus phi of 2.1. So it will be 1 minus 2 into 0.4821. 2 into 0.4821. Equal to 1 minus 0.9642 be 0.0358. Okay, this is the answer. P norm 2.1 is that. Nothing I'm going to ensure. .98 21356. Okay, so this will be 0.21 481. I'm getting maybe some discrepancies are there. Anyway, alright, so we just have to find out this thing. Alright, this one we have done. This is essentially this question. Assignment alright, so that leaves us with 2 more questions for the day. We'll solve it and then wrap up. Alright, so let xn be a sequence of random variables such that this holds. We have to show that xn converges in distribution to exponential 1. So limit n tends to infinity f of xn x equal to 1 minus 1 minus 1 by n to the power nx if x greater than 0 and 0 otherwise. So limit this one is limit of this one if x greater than 0 and 0 otherwise. So this one is limit n tends to infinity 1 minus 1 by n to the power n and x. This is 1 minus limit n tends to infinity 1 minus 1 by n to the power n x. So this limit limit n tends to infinity 1 minus 1 by n to the power n is equal to e. So nx will be e to the power x. So then what do we have? Limit n tends to infinity f x n x equals to limit n tends to infinity 1 minus 1 by n to the power nx 1 minus limit n to the infinity 1 minus 1 by n to the power nx. So this one is 1 minus e to the power so sorry, this one is e to the power this is e to the power this thing 1. So similarly this will be to the power minus 1 into x. This is 1 minus e to the power minus x, which is equal to fx of x, where x follows exponential 1. Alright, so now we are going to move on to the last question for today. So we have been given that we have to consider a sequence where xn takes minus 1 by n and half 1 by n with probability half and half, show that xn goes to 0 in absolute sure sense. So we have to show that probability xn minus 0 greater than epsilon, this converges. Then that would imply limit xn goes to 0. With probability 1. So this one we have to show n equal to 1 to infinity xn greater than epsilon xn is 1 by n. Okay, so mod of 1 by n will be greater than epsilon when n is less than 1 by epsilon. So this will be non-negative if we have n equal to 1 to box function of 1 by e, probability xn greater than epsilon. Okay, so this probability is 1. Xn greater than epsilon when n is less than this condition is holding, this is half plus half, so this is 1. So we'll have n equal to 1 to 1 by epsilon half plus half. So then this one is equal to box of 1 by epsilon, which is less than infinity. Therefore we say that xn goes to 0 in absolute sure sense. Okay, So this was all about limit theorems. uh, so since I'm getting some feedback that the team has still not posted solutions, maybe what I'm going to post some of the solutions that I've not done here. I mean, maybe not post, maybe in the next couple of weeks I'm going to solve a few more assignment problems, and then if you have any doubts you can just join and get it clarified. All right, thank you so much for whoever has joined, and I'll see you next week.